Hello students, I am Rashmi Vadla, Assistant Professor of Science and the Institute of Technology and Management, Gurgaon from ETCE department. Today's topic is interrupts from your microcontroller and embedded system. So first of all, what do you mean by interrupts? Basically, interrupts may be a positive or negative. Don't take in that negative sense that interrupt in negative sense, ki disturbance and all. Yes, it is disturbance, but it is a indication specifically about any requirement or about any need, immediate attention is like that. So we can say that ki or you can say that to stop the progress of something for a short time, or we can say that key interrupt is in a response by the processor to an event that needs attention from the software. So interrupt is in a signal to the processor emitted by the hardware or the software indicating an event that needs immediate attention. Whenever an interrupt occurs, the controller completes the execution of the current instruction and start the execution of an interrupt service routine or an interrupt handler. ISR tells the processor or controller what to do when interrupts occur. The interrupts can be either hardware or a software. When we discussed about, when we studied in 885, the microprocessor having a five interrupts, five hardware interrupts basically, that is SRAP, RST 7.5, 6.5, 5.5, and INTR. So these are the 885 interrupts. Now we are discussing the microcontroller interrupt. So we can classify the interrupt into two parts, that is hardware interrupt and software interrupt. A hardware interrupt is an electronic alternating signal sent to the processor from an external device like a disk controller or an external peripheral. For example, when we press a key on the keyboard or move the mouse, they trigger hardware interrupt which causes the processor to read the keystroke or a mouse position. Software interrupt is what? A software interrupt is caused by either by an exceptional condition or a special instruction in the instruction set which causes an interrupt which is executed by the processor. For example, if the processor arithmetic logic unit runs a command divide a number by 0 to cause a divide by zero exception, then this causing the computer to abandon the calculation or a display an error message. Software interrupt instruction works similar to the subroutine calls. सो एक definition आती है polling or a concept of polling. What is polling? The state of continuous monitoring is known as polling. The microcontroller keeps checking the status of other device, or while doing so, it does no other operation and consume all its processing time for monitoring. This problem can be addressed by using interrupts. In the interrupt method, the controller responds only when an interruption occurs. Thus, the controller is not required to regularly monitor the status of interfaced and inbuilt devices. You can say that see the difference between the interrupts and polling. Basically, interrupt may the controller respond only when the interruption occurs. But in polling may the microprocessor keep checking the status of other device and while doing so. So this is the basic real life example of interrupts and polling. An interrupt is like a shopkeeper. If one needs a service or product, he goes to him and praises him for of his needs. In case of interrupts, when the flag or a signals are received, they notify the controller that they need to be serviced. Polling polling method is like a salesperson. The salesman goes from door to door while requesting to buy a product or service. Similarly, the controller keeps monitoring the flags or a signal one by one for all devices and provides service to whichever component that needs its service. Now, what do you mean by interrupt service routine? For every interrupt, there must be an interrupt service routine or an interrupt handler. When an interrupt occurs, the microcontroller runs the interrupt service routine. For every interrupt, there is a fixed location in memory that holds the address of its interrupt service routine ISR. Interrupt service routine is in my ISR, and it is a fixed location in the memory which holds the address of its interrupt service routine. The table of memory location is like set aside to hold the addresses of ISR is called interrupt vector table. So this is the main execution program without interrupts. This is the two figures, that is my main program with respect to time. This is why without interrupts. But this is my main program with interrupts. Then the main program ISR, main program ISR. ISR is interrupt service routine. So this is a fixed memory location that holds the address of its interrupt service routine. This is my interrupt vector table. There are the six interrupts including REST in 8051. So these are the interrupts, that is serial communication R1 and T1, timer 1 interrupt, external hardware interrupt 1, external hardware interrupt 0, timer 0 and reset. So the serial communication is 0023, timer 1 is 001B, external hardware interrupt 0013, external hardware, if they are the fixed location, you have to learn all these locations. 003 and timer 0000B, 000B, and reset having a four zeros. And these two pins, these two interrupts are on the pin number 12 and 13, and for the port 3.2 and port 3.3. So there is a interrupts having their location in the ROM, and these are called as interrupt vector table. When the reset pin is activated, the 8051 jumps to the address location 0000. This is the power up reset. Two interrupts are set aside from the timers, one of the timer 0 and one for timer 1. So memory locations are 000B and 001BH respectively in the interrupt table. So क्या है आपके पास दो interrupts हैं टाइमर के लिए, टाइमर 0 and टाइमर 1 के लिए, and टाइमर 0 टाइमर 1 की ये लोकेशन है in the interrupt vector table. Two interrupts are set aside for the hardware external interrupts. Pin number 12 and 13 in the port 3 are for the external hardware interrupt, that is interrupt 0 and interrupt 1 respectively, and memory locations are for interrupt 0 and interrupt 1 are 0003 and 0013H respectively in the interrupt vector table. Serial communication has a single interrupt that belongs to both transmit and receive, so memory location 0023 belongs to this interrupt. Step to execute an interrupt. When an interrupt gets activated, the microcontroller goes through following steps, that The microcontroller closes the currently executing instruction and save the address of the next instruction on the stack. It also saves the current status of all interrupts internally. It jumped to the memory location of the interrupt vector table that holds the address of the interrupt service routine. The microcontroller gets the address of ISR from the interrupt vector table and jump to it. It starts to execute the interrupt service subroutine, which is RETI, that is return from interrupt. So when upon executing the return instruction RET, the microcontroller returned to the location where it was interrupted. First, it get the program counter address from the stack by popping the top bytes of the stack into PC, and then it start to execute from that address. Next is the edge triggering and level triggering, edge triggering versus level triggering. So level triggering is a level triggered interrupt module always generate an interrupt where the level of the interrupt source is asserted, and the edge triggered interrupt module generate an interrupt only when it detects an asserting edge of the interrupt source. The edge get detected when the interrupt source level actually changes, and it can also be detected by periodic sampling and detecting an assert level when the previous sample was deasserted. If the source interrupt is still asserted when the firmware interrupt handler firmware interrupt handler handles the interrupt, and the interrupt module will generate the interrupt causing the interrupt handler to be invoked again. बेसिकली जो लेवल ट्रिगर्ड इंटरप्ट है, ये जब हमारा लेवल हाई होता है या लेवल लो होता है तो ही हमारा एक्टिव होता है, और एज में हमारा या तो पॉजिटिव एज है या नेगेटिव एज है, दो तरह से एज को हम डिफाइन करते हैं, तो ही हम अपना एज ट्रिगर्ड इंटरप्ट हमारा एक्टिव रहता है. And edge-triggered interrupt modules can be acted immediately no matter how the interrupt sources behave. And edge-triggered interrupts keep the firmware's code complexity low and reduce the number of conditions for firmware and provide more flexibility when interrupts are handled. Now, enabling and disabling an interrupt. Upon reset, all the interrupts are disabled even if they are activated, and the interrupt must be enabled using software in order for the microcontroller to respond to those interrupts. I is the interrupt enable register, which is responsible for enabling and disabling the interrupt, and IE is the bit addressable register. Next is the interrupt enable register, that is EA, global enable oblique disable. ET2 is for the timer 2, ES for the serial port interrupt, ET1 is for the timer 1 interrupt, EX1 is for the external 1 interrupt, external interrupt timer 0, external interrupt enable 0, that is EX0. So EX0 and EX1 is same. ET0 and E1 for the timer 0 and timer 1, and EX0 and EX1 for enable external 0 interrupt and enable external and 1 interrupt. Next is to interrupt and to enable an interrupt, we are taking following steps, that is a bit D7 of the IE register must be high to allow the rest of register to take effect, and if EA is equals to 1, then interrupts will be enabled and will be respond to if their corresponding bits in the IE are high, and if IE is 0, and no interrupt will be respond even if their associated pin in the IE register are high. Interrupt priority in 8051, that is we can alter the interrupt priority by assigning the higher priority to any one of the interrupt. This can be accomplished by the programming register, that is a interrupt priority registers, This shows the bit of the IP register, and upon reset, the IP register contains the zeros. To have a higher priority to any of the interrupt, we make the corresponding bit in the IP register high. So this is the format. This for the PX0, that is for IP0, IP1, IP2, IP3, IP4, IP5, IP6, IP7. So this when IP0 is for that is PX0, that defines the external interrupt 0 priority level. This defines the external interrupt 1 priority level. This defines the timer 0 interrupt priority level. This defines the timer 1 interrupt priority level. And for IP4, IP5, IP6, IP7, no implemented. Next is interrupt inside interrupt. What happens if the microcontroller 8051 is interrupt executing an ISR that belongs to an interrupt and another one get active. मान लो एक इंटरप्ट हैंडल कर रहा है 8051 और इतने में दूसरा इंटरप्ट एक्टिव हो जाता है, तो इस केस में 8051 क्या करेगा? इन सच केसेस अ हायर प्रायोरिटी इंटरप्ट कैन interrupt a lower priority interrupt. This is known as interrupt inside the interrupts. तो उस केस में जो higher priority interrupt होगा वो interrupt कर जाएगा low priority interrupt को. And in 8051, a low priority interrupt can be interrupted by a high priority interrupt, but not by any another low priority interrupt. Next is the triggering and interrupt by software. There are the timers when we need to test an ISR by a way of simulation. This can be done with the simple instructions to set the interrupts high and thereby cause the 8051 to jump to the interrupt vector table. And for example, the IE bit as a 1 for the timer 1 and instruction set B TF1 will interrupt the 8051 in whatever it is doing and force it to jump the interrupt vector table. So this is for the triggering and interrupt by the software. So this is all about the interrupt, student. If there is any doubt, you are free to ask. Thank you, students. Thank you so much.